everyone, Sukanya here. Today we're going to be solving this pretty tricky integral where we're actually going to be proving that this integral is equal to this integral as well as this answer. So first we are going to break this apart into two. I'm going to first prove that this is equal to this. Then later on I'm going to prove that this is equal to this. So let's start with this is equal to this. So on the right, you see there are two formulas or like hints I've given you in case you want to give this problem a go. So this is the first hint and that is the second hint, but I'm going to go over the solution right now. So in order to prove that integration 0 to pi over 2 log sine x dx is equal to integration 0 to pi over 2 log of cos x dx, we are going to use our second hint or our second formula. And in order to do that, we need to know what a is. A is the upper bound, correct? So our a is just going to be pi over 2. So we are going to substitute a is equal to pi over 2 on this side. So I'm going to let this 0 to pi over 2 log of sine x dx. I'm just going to set that equal to I for a moment, and I do this in a lot of my videos. If you don't know why I set it equal to I, it's going to make much more sense later on, but I'm just going to set it equal to I for integral, and I'm going to say I is equal to integration 0 to pi over 2, and now I'm going to apply this formula over here. So that is equal to f of a minus x. We know a is pi over 2 minus x dx. I know that f of x is log of sine x. So this integral will be integration 0 to pi over 2 of log of sine pi over 2 minus x dx. And lucky for us, we automatically know that sine pi over 2 minus x, well, that is equal to just cos x. And just like that, we have proved that this is indeed equal to this. So that wasn't as hard as, well, we were expecting, but when we are proving this to this, that is where it gets a bit more tricky or a bit more involved. And that is also where we need to use our first hint. So what I'm going to do right off the bat is that I set I equal to integration of log sine x dx, but I also proved that I is equal to integration log of cos x. So I'm going to add these equations together. And what I mean by that is I'm going to do I plus I, which is 2I. And this is why I set the original problem equal to I. And I'm going to add this integral and this integral. So that's going to look something like 0 to pi over 2 plus integration 0 to pi over 2, once again, of log cos x dx. And the reason I'm adding these is because if I add them, I can simplify this part a lot. So in order to simplify it, I'm just going to make these two integrals as one integral because the lower bound and the upper bound are the same. Alright, and according to the properties of logs, we know that log a plus log b is equal to log a times b, so I'm going to apply that over here. And I want to simplify this a little bit more. I am aware that 2 sine x cos x is equal to sine 2x, but of course we don't have a 2 over here. We're missing that 2, so I'm just going to multiply the top by 2, and then I'm just going to divide the bottom by 2. Either way, it's still sine x cos x. And from here, I can now replace 2 sine x cos x with sine 2x. So I'm going to do that right now. So now I am going to, once again, apply the properties of log. I know that log a over b is equal to log a minus log b. So I'm going to apply that here. And now I'm going to split this into two integrals because I see that this is just a constant, and if I split that into its own integral, it's going to become pretty easy to solve that. So I'm going to split this into two integrals. And now I'm going to simplify this integral, and I'm going to leave this part the same. So I'm going to have 2I is equal to integration 0 to pi over 2 of log sine 2x dx minus, and this is just going to be log 2, and then I'm going to have x over here, 0 to pi over 2. Alright, so we simplified a lot. Just to remind you guys, what we're trying to do is that we are trying to prove this I is equal to negative pi over 2 log 2. So essentially all we have left to solve is this integral right over here. So I'm going to label this as, let's say, I1. So we're just going to be solving I1. but then we're going to substitute whatever we get for I1 back into this equation over here. When we are solving for I1, I think we should get rid of this 2x and just start applying u substitution. So I'm going to say let u equal to 2x, therefore du is equal to 2 dx, and therefore dx is equal to 1/2 du. So I'm going to say I1 is equal to integration, and now the bounds will change, but I'm just going to leave that blank for now. We're going to come back to it a bit later. We're going to have log of sine of u, and then we said dx was 1/2 du. Now we can worry about those bounds. So I know that when x is equal to the lower bound of 0, right over there, then u will have to be equal to 2 times 0, which is also just 0. And when x is equal to the upper bound of pi over 2, u is equal to 2 times pi over 2, which is just pi. So our new bounds are 0 to pi. And then I'm just going to take that 1/2 out because it's a constant. All right, so now from over here, we can't really simplify it anymore. I mean, we can't use u substitution. I mean, we can use integration by parts if we really wanted to, but there is a simpler method than using integration by parts, and that is where our first hint comes into play. All right, so we have our first hint to the right side, and we have our I1 simplified. Now we are going to apply the first hint. So in order to apply the first hint, let's actually see what the first hint says. It says if we have an integration 0 to 2a of f of x dx, that is equal to 2 integration 0 to a of f of x d of x, only when f of 2a minus x is equal to f of x. And if f of 2a minus x is equal to minus f of x, then the integral is just equal to 0. So in order to do this, once again, we need to figure out what our value of a is. So we know that 2a over here is our upper bound. So if 2a is our upper bound, if 2a is equal to pi, then we know a has to be half of that, so a is equal to pi over 2. Now we need to figure out which scenario are we using, right? Are we using the one where it's equal to f of x or the one where it's equal to negative f of x? So in order to do that, we need to find what f of 2a minus x is equal to. So let's do that right now. So we have f of 2a minus x. I know that 2a is equal to pi. And then I know that x is just minus x. And from here, I'm going to replace it in here. And over here, I realize that there is a little bit of discrepancy. Our function is in terms of u, but our hint is in terms of x. Either way, they're the same thing. I can just switch this out for u. Either way, it's just a variable. U is a variable. So now I'm going to replace this u for pi minus u. And I know that sine pi minus u is just equal to log of sine u. And that was exactly the original function we started with. So that is equal to f of x or f of u in this case. So hence, it's not equal to minus f of u, so we do have to apply this integral right over here. So I'm going to rewrite I1 as 1/2 because we do have that 1/2 over here. And this is going to be equal to this part right over there. So 2 integration 0 to a or 0 to pi over 2 of f of x, in our case f of x or f of u is going to be log of sine u du. Simplifying this 2 and this 2 get canceled. We're just left with I1 is equal to integration pi over 2 log of sine u. And what do you know? This was actually our original problem. So I1 is equal to just I. And this actually comes pretty handy because when we go back to our original problem and then we put the value of I1 in here, we are left with 2i on the left side. Nothing changes with that. But then we are left with I because we just said I1 is equal to I. And then we're going to leave that as it is, minus pi over 2 log of 2. Simplifying this, I get I is equal to negative pi over 2 log of 2. And that is exactly what we needed to find. The second part was definitely a bit trickier than the first part. The first part, we just needed to know some trigonometric identities. But for the second part, we did need to know this handy little formula, which wasn't too bad as it seems. Just remember, for this formula to apply, first identify what your a is going to be, what your constant is, and then identify if you're going to be using this part or this part. And that is it for Mathmania today, and I'll see you guys next time.